It is Tuesday. We're talking about Linux OS 2. So we reviewed processes and led that into threads, and then from threads we talked about synchronization and initially talked about schedules. So that took up a good share of the class. Then we did some command line items, and what we did was we may not get completely done, but we started looking at setting up static addresses in the workstations in class. We did very little to nothing on files and directories at this point. So we are in week 4, day 7. We won't cover all the details here, but let's talk a little bit about this. We discussed the difference between a program stored in memory, or stored on storage somewhere, and you bring it into memory, it becomes a process, and it develops this memory map. So we have the, let me just review these. We have the text. These are the machine instructions. This is the code. Then we have some static and global data, and then we have the heap, dynamically allocated memory, and then we have a stack that keeps track of what's what. Okay, we're going to refer back to that here in just a minute. We talked about the execution context. Let me clarify. You have instructions that are being executed. You have this list of instructions, maybe that'll be easier, that are being executed. So we have to keep the context of where we are, because we have systems that work on multiple processes, or multiple processes are in memory that we talked about previously. And so we have to be able to switch from one to another. So the execution context is, where is it at in the execution, so that you execute the next correct instruction. Now, what we can do is we can keep the main part of the program and divide up these executions context into threads. I'm being very vague there on purpose. Okay, in the stack we have the instruction pointer and the registers, and we can create threads. So one program, we have a program process block, or program control block, sorry about that. So we have a program control block that we can use where all the information is kept concerning that particular process, and then that can split, if you want to think of it that way, into these threads. Thread control block. Okay, so it's almost like taking this part of this and having multiple ones. We have the same shared area here, but we can run separate threads. The example I gave in class, let's use word processing. You're typing on a word processor, and that I/O is very slow for the computer. It can be managing that in a thread. It could be managing looking for spelling in a thread, making words red if they don't spell right. Okay, and it's managing putting the items on the screen so they look decent. So you can have separate threads, one program, okay, doing multiple things, and that's possible now because we have multi-core processors. Now, to make all that work, we have to be able to synchronize. We have some things that can run concurrent. We have parallel. If you're running threads in parallel, or processes even in parallel, typically we refer to parallel, we have separate processors. Asynchronous, what order? Some threads can run independently. And you need to be able to think about some of these threads have to be synced. So when one thing gets done in a thread, it matches with something else. Okay? Alright. Then, how does the operating system schedule this? Let's take a look. A lot about scheduling. But a lot of work inside the computer. We have a lot of work done by the computer, and then the processor, and then we have a lag, and then we have a lot of work here done with the processor. And the processor is so fast that typically it's only working a small amount of time and waiting a lot of the other time. Some things are processor intensive, so it's a lot of time on the processor and not much lag in between. Okay? So we want to schedule events to keep the processor as busy as we can with lots of things going on. Well, we're going to talk more next week about scheduling, but when we talk about a preemptive operating system, it allows us to create an interrupt. So even though these things are happening, we can have an interrupt and process some things here and then come back to those. What could cause an interrupt? All kinds of things. I gave the example of a car, has computers on board, and they have operating systems, and they're processing, and all of a sudden the car runs into something, and the front end collapses. Now there has to be, you can think of it as an interrupt to what it was processing, and it needs to process the instructions to inflate, I suppose you'd call it, the airbags. Make sense? Yeah. Alright. Well, that's it for processes and threads. So you can just think of it. You can have one program can have multiple threads going on. Okay? Now, let's take a look at some updates to the network here. We have a firewall. Okay, firewall. And we have a couple ports coming out of that firewall. We have one going to a DMZ. Okay. We have another one going to our inside network. And then we have another one to our outside network. They have security policies. 100, 50, and 0. Traffic can move from a higher security policy to a lower one. So traffic will move freely this way, and the firewall will keep track of that traffic and allow traffic back in. If traffic generates from a lower number, it cannot enter a higher number unless we specifically give it permission. Alright, we moved the work servers. Work server 1, work server 2 to a new network. So they have these new addresses internally. They're external addresses, okay? For example, 207, 165, 226, 184. Those are the same. Or this would be 85. 185. Let me 185. Those would be the same. 207, 207, 165, 226, 184. The external addresses are the same. They just map to a different address internally. So if we're internal, we can be here and we can access both of those because we're going from a higher security number to a lower one. If we're coming from the outside, okay, if we're coming from the outside, to get through the firewall we have to have specific permission, which I set up in the firewall to access these using their public IP addresses. Okay. Now, one thing's changed if you're a networking student. In order to get to the NIAC access in order to be able to console into equipment, you have to use this address once you log into these servers instead of this one up here. So the change comes more so when you come in from the outside and you need to get to the networking equipment through this device. Otherwise, a lot of people will not notice the change. Okay? Now, if you're internal here though, and you need to use the workstations, then you have to use their new addresses internally. All right. We did some work from root. We looked at IF config. We looked at IP route. We here went to a directory here and looked at some network information concerning the interfaces of our workstation. And what we did was we changed when they boot to none. It was DHCP, and then we went in and assigned IP addresses, and we moved them to the DMZ. So these were the addresses assigned, and you'll notice they're on that network on the DMZ. We will follow up with that on Thursday. Last thing, we have coming up, we have a unit evaluation on Tuesday, and we'll review that on Thursday. All right, that is it.